So I'm going to answer the Physics Test 6 review questions. So let's get started. A ball is thrown at an angle of 38 degrees to the horizontal. What happens to the magnitude of the ball's vertical acceleration during the total time interval that the ball is in the air? We don't even need to know the 38 degrees because whenever something is in the air, the vertical acceleration is always negative 9.81 meters per second squared, and so it remains the same. The second question asks, if a basketball player jumped straight up to grab a rebound if she was in the air for 0.8 seconds, so the total time, how high did she jump? This is dy. Now, to do this type of problem, we have to decide where the initial position is and the final position is. So let's draw a little picture. So for a rebound, she's going to go straight up and then back down again. And I'm going to make it so you can see it a little bit, the up and the down, okay? Whenever we do a question like this, it's very useful to choose the initial position as the peak and the final position down on the ground. And that's because at this peak position, our vertical initial velocity will become 0, and that's very useful. Let's set all this up. I know it takes some time, but it organizes you. X, and what's shared is t. The vertical dy, that's what we're looking for. Okay. VIY, VFY. We may not need all of these variables, but we list them out anyways. So the peak, we're going to start from the peak. It's 0 meters per second because at the peak it's going from a positive velocity and then changing to a negative velocity. And to go from positive to negative, you have to go through 0. This is negative 9.81 meters per second squared. dx is 0 meters and vx is 0 meters per second because it's not moving at all. The basketball player isn't moving at all in the x direction at all. Now, how much time does it take to get from the peak down to the ground? Well, for the total time, it takes if you look at this, it took 0.8 seconds, right? So if the total time takes 0.8 seconds, then to the peak, it's going to take, to the ground, it's going to take only 0.4 seconds. So that's our time. It's half the time of the total. So now we have enough information to solve for dy because d is equal to vit plus 1/2 at squared. And you can see that vit is going to go to 0 because VIY is 0, so that goes away. So we're going to find what dy is. We're going to have 1/2 times negative 9.81 times the time, 0.4 squared. This is going to give us a dy of negative 0.78 meters, but that's okay because we went down from the peak. That's why it's a negative value. So that means the total height jumped was 0.78, and that will be answer B. All right, question number 3. A golf ball is hit with an initial velocity of 15 meters at an angle of 35 degrees above the horizontal. What is the vertical component of the golf ball's initial velocity? So what we would do is we'd have 15 meters per second at an angle of 35 degrees. We want to know what the vertical component is, which would be the part that is going up like this. I kind of ran into that 15. You could also write it over here, right? And if we do that, we can see this is the horizontal, this is the Vx, this is the Vy. And so we could use equation number 6 on your reference tables, and that would say Vy is equal to V times the sine of theta, and we would get Vy equals 15 meters per second times the sine of 35 degrees. If we calculate that out, and then we get 8.6 meters per second, and that's our answer right there. Okay, let us go to question 4. It says a projectile is fired from a gun near Earth's surface. The initial velocity of the projectile has a vertical component of 98 meters per second and a horizontal component of 49 meters per second. How long will it take the projectile to reach the highest point in its path? So this is nice because it gives us a really nice point where the initial point is and the final point. So this will be our final point, and this is our initial point. Okay, so let's go set that up in our, let me see, right here. Okay, so we have an initial vertical of 98 meters per second and 49 meters per second, and the velocity is going to go up like this, and then our projected path will go up like this. Okay, and our peak. So this is going to be our final position, and this is our initial position. Let's set it up. I'm just going to say H for horizontal, V for vertical, and we'll put a spot for the T as well. So dx, vx, dy, viy, vfy, and a. Negative 9.81 meters per second squared. Now our final velocity at y, it's at the peak, so that's very nice. So that's 0 meters per second. Right? Our inertial y velocity is 98 meters per second. And we don't know really anything else. Now our goal is to find time to the peak, right? So we're looking for time. So what we can do is use equation 3, which is Vf equals Vi plus At, right? So Vf is 0 meters per second, Vi is 98 meters per second, minus 9.81 times T. Subtract over the 98, we get negative 9.81 T, divided by negative 9.81 on both sides. This cancels out, and T comes out to be about 10 seconds. And that's our answer. Okay. A child kicks a... We're going to use the following information to answer the following question, number 5. So a child kicks a ball with initial velocity of 8.5 meters per second at an angle of 35 degrees with the horizontal, as shown here. The ball has an initial vertical velocity of 4.9 meters per second and a total time of flight of 1 second. The horizontal component of the ball's initial velocity is approximately what? Well, there's a lot going on here, and all we have to realize is that the horizontal component of the ball's initial velocity is just this value right here, Vx, right? And Vx can be calculated from V times the cosine of theta. So Vx is going to be 8.5 meters per second times the cosine of 35 degrees. And that will give us, let's see, times 35 cosine, 6.9 meters per second, which is 7 is the closest, so that's going to be our answer. Number 6. After a model rocket reaches its maximum height, then it took 5 seconds to return to launch site. What is the approximate maximum height reached by the rocket? So, our initial spot will be the maximum height after it's reached the maximum height. It's going to return to launch site. That's going to be our final position. So let's see what that is. So the rocket is going from the ground, it's going up, and then it's coming back down. Okay, so this is going to be our initial and our final. Remember, initial is, the peak is a great spot to have initial position. Oh, I gotta see, what we're looking for? The maximum height, so that's going to be our D dy. Okay, so horizontal, vertical, dx, vx, put t in here, dy, viy, vfy, a, negative 9.81 meters per second squared. Our dy, that's what we're looking for. Okay, our vi is 0 meters per second at the peak there. Vf, we don't know what that is. Okay. Which equation can we use to find dy? Oh, we also have 5 seconds. Great. So that's going to help us. 5 seconds. So I think we're going to use equation 4. So d equals vit plus 1/2 at squared. Because viy is 0, that drops out. Our distance is what we're looking for. 1/2 negative 9.81 time is 5 seconds squared. And so if we solve for d, then we would get a negative value, right? 25 times. We would get negative 123 meters. All right. But our height obviously is going to be a positive value. And because they had the 5 seconds was 5 seconds has only two significant figures, our answer is going to be C, which has only 2 significant figures as well. Number 7, an archer uses a bow to fire 2 similar arrows with the same string force. One arrow is fired at an angle of 60 degrees with the horizontal. The other is fired at an angle of 45 degrees with the horizontal. Compared to the arrow fired at 60 degrees, the arrow fired at 45 degrees has a what? So we're going to go with the same initial vertical velocity, one at 60 degrees and one at 45 degrees. Okay, now there are some things we should realize. 45 degrees will have the longest range, so that will go farther. But if we're shooting higher up, like the 60 degrees, that's going to take a longer time to fly. So compared to the arrow with 60 degrees, this is a shorter time, but a longer range. This is a longer time and a shorter range. Okay, so we are going with the shorter time and the longer range because we're comparing it to the 60 degrees. So shorter time and longer range. That would be C. Okay, question 8. The diagram below represents the path of an object after it was thrown. What happens to the object's acceleration as it travels from A to B? We've seen this question before. The only acceleration is in the vertical, and it's negative 9.81 meters per second squared, so it remains the same. Question 9. The diagram shows a student threw a baseball horizontally at 25 meters per second from a cliff that's 45 meters above the ground. How far from the base of the cliff does the ball hit the ground? That would be dx. If we had time, this would be really nice, but we don't. So let's go ahead and set this question up. Okay. So we have this let's see, 45 meters. It's going to go 25 meters per second. Okay, H and V. Okay, dx. Is this getting old yet? But it's going to make it work out right. dy, viy, vfy, and this will be, So negative 9.81 meters per second squared, and this is going to be our initial position. This is going to be our final position over here, and we want dx. Oops, that didn't work out. Okay, here we go, dx. And we have our dy is negative 45 because we went down. Our initial horizontal velocity is 25 meters per second. Our initial y is 0 meters per second because it's not moving up or down at all. And so we want Vx, and to find Vx we have to find time. So we have to use the vertical values to find time first. Let's see. So let's see what equation we could use. I'm going to use equation 4, Vit plus 1/2 at squared. This goes to 0 again. So distance negative 45 1/2 negative 9.81 t squared. We're going to solve for t real quick here. What is going on with my calculator times? So I got about 3 seconds. 3 seconds. Now we're going to use our only equation that we use in this direction. Okay, so we've got Vx is 25 meters per second. Oh, I made a huge mistake right there, didn't I? This should be right here, 25 meters per second. And we're not looking for Vx. We're looking for dx. All right. Okay, so let's plug these values in now. We would have 25 equals dx over 3 seconds. And we'll multiply by 3 on both sides. That cancels out, and we get dx equals 75 meters. So that's our value, that's our answer, and we can write that right here. Projectile A is launched at 20 meters per second off a cliff, and so this is A at 20 meters per second, and it's going to go off and it's going to smack down at the bottom. Then we got a similar object, and it's the same cliff, same height and everything. This is 30 meters per second. It's going to go off and it's going to smack a little farther. But our initial vertical velocities are 0 meters per second because we launched these things directly horizontal, all right? And so the time for each of them to land is going to be the same amount. And we know that the time for projectile A was 3 seconds. So the time for projectile B is also 3 seconds. So that's the answer to that. No calculation required. Now, how high is the cliff? We do need to calculate that. Just use the same methods that we've been doing. We could also kind of see from the previous problem, if you remember, I found that this time was about 3 seconds. And so you can see that the cliff is 45 meters, and so this is also going to be 44 meters. I'm not going to do this one in detail. Okay, number 12. A projectile has an initial horizontal velocity of 15 meters per second and an initial vertical velocity of 25 meters per second. Determine the projectile's horizontal displacement if the total time of flight is 5 seconds. Okay, so we can do horizontal, vertical, and it's asking for the horizontal displacement. And we already have the time, so let's put that in there too. Time is 5 seconds, and it says the vertical, or the horizontal, is going to be horizontal velocity is 15 meters per second, 15 meters per second. The vertical velocity, initial, I, is 25 meters per second. But this asks for dx, and we only have one equation for horizontal, which is going to be our Vx equals dx over t. And we already have 2 of them to solve for it. So our t can go in here, and our vx can go in there, and we can solve for dx, and dx will turn out to be 75 meters, and that is the answer for that one. Projectile is launched into the air with initial speed of vi. Doesn't say what the vix and viy is, but just vi, at an angle of 30 degrees above the horizontal. The projectile lands on the ground 2 seconds later. On the diagram above, sketch the ideal path of the projectile. So it's going to be like a parabola, like this. Boink, and that's all you have to do. How does the maximum altitude of the projectile change as the launch angle is increased from 30 degrees to 45 degrees above the horizontal? So if we're going to change this altitude, and it's going to go up higher like this, we're making it up to 45. That looks like it's higher than 45. But as we go higher, the altitude will also have to get bigger. Because if we're shooting something straight up, it's obviously going to go higher than if we're doing it at an angle. All right, so from 30 to 45, it's going to increase. All right, the maximum altitude will increase. You could make that a full sentence. How does the total horizontal distance traveled by the projectile change as the launch angles increase from 30 to 45? Well, the maximum distance something can go is when it's at 45 degrees, all right, horizontally. That's the best distance you can get, okay? So if it's going from 30 to 45, this will also increase the horizontal distance. Okay, so we got 3 questions. A projectile is fired from the ground with an initial velocity of 250 meters per second at an angle of 60 degrees above the horizontal. On the diagram below, use a protractor and a ruler to draw a vector to represent the initial velocity of the projectile. Begin at point P and use a scale of 1 centimeter equals 50 meters per second. Well, we got 250 meters per second, right? And if the scale is 50 meters per second to 1 centimeter, we can use conversion factors here to find out that the value has to be 5 centimeters long. Okay, it's going to be 5 centimeters long at an angle of 60 degrees. I'm not going to measure perfectly, but I'm just going to go like this. And then you label this 250 meters per second, and this is 60 degrees. 17. Determine the horizontal component of the initial velocity. So the horizontal component would be that which is going in the horizontal direction. So we know that it's going to be 250 meters per second times the cosine of 60 degrees. That's how fast it's going in the horizontal direction. So 60 cosine of that, oh, yep. So it's 125 meters per second. Explain why the projectile has no acceleration in the horizontal direction. This is because in the horizontal direction, the net force is 0. And that's why you have no acceleration in the horizontal direction. Okay, that is it for this video. Hopefully you find it useful. Thank you.